Repairing a 2-inch scale Fowler traction engine, part 1. An overview of the job, what is wrong with it. Well, the first thing that's wrong with it is it's very heavy. This traction engine belongs to a man called Sean, and on the day it arrived at the workshop it took 3 of us to get it onto the bench, sort of in shifts. Sean lifted it out of the car by himself, and then we put it on the picnic table, then it was lowered onto the ground and wheeled along the path towards the workshop. And eventually inside the workshop it was put on the bench. Unfortunately, I got the heavy end. If you ever want to lift a traction engine, make sure you pick up the front bit. As the title would suggest, this is a 2-inch scale Fowler traction engine. While Sean and his partner Wendy were with me in the workshop, I had a really good look around the engine in an attempt to find out what was wrong with it, but I'm sure as the job goes on I will find a lot of other things wrong with it. What I'm actually looking at the moment is an engine that's very worn. As you can see, it appears to be very well made. In this clip I'm checking the front wheels, and there's a bit of play on the chain, but that's normal. The wheel bearings feel okay. Sean was telling me that he'd ridden behind this engine for quite a few miles. The engine's very good looking. There are 1 or 2 things amiss with it though. If you look at this, it's the governor that sits on top of the block. And someone has secured the gear to the shaft with a rather large screw which stops the shaft from rotating. This is not a big problem because I'm not going to connect up the governor. Sean told me that he fitted a new mechanism to the lubricator, as the original one stopped working. He also fitted this coin with the Queen's head on it in the top of the lubricator cover, which is a nice touch for the Queen's Platinum Jubilee. I'm going to replace the linkage that drives the oil pump, mainly because the one that's fitted doesn't look very good. Time to check out the mechanical aspect of the engine. I can immediately see a couple of problems. The valve fork on the valve rod is loose. In this close-up you can see that it's moving around and it shouldn't be. And also, in common with most traction engines, including my large 4.5-inch scale one, the expansion link touches the top of the boiler when it's in the lowest position. I removed the cover from the end of the flywheel to see what was going on because the flywheel was sliding back and forth on the crankshaft. In fact, the entire crankshaft had a lot of movement in this direction, which is not good. But once I fix the flywheel problem, this side plate should disappear. This first video is only the overview. I'm not doing any work on the engine, just looking at what's wrong with it. That's job 1, sort the flywheel and crankshaft out. And here's another job that's going to take quite a bit of fixing. This part is called the crosshead, which connects the small end of the connecting rod to the piston rod, and this needs to be held firmly between 2 guides, which are called crosshead guides. But this is not very firm at the moment. This crosshead design uses what are known as slippers, and the good thing about using crosshead slippers is the crosshead itself doesn't wear. All you do after a while, when the whole thing gets worn like this, is remove the slippers, make some new ones, a little bit bigger, and then refit them. There's quite a lot of play in the crosshead pin, but this is worse. Look at the amount of play in the piston. What is going on here? Once I've made new slippers for the crosshead, I would think it would be a good idea to make a new gland from some phosphor bronze to support the piston and hold it in the right position. As I move the camera forward to the cylinder, I can see that one of the drain cocks is broken, and there has been an attempt to superglue it back in position, which is not really going to work. From what I'm looking at, I can see that the original builder of this engine was quite a good engineer. It's very well made, but the passage of time and subsequent owners who are not engineers have taken their toll. Just look at this linkage, it needs a proper crosspin making. By the way, I'll just mention that this whistle is horrific. It really works, but the frequency of it is painful. It has a sound that would attract most dogs in the neighbourhood. Before I start running the engine, this is a safety precaution, and I always do this when I'm working on traction engines. I'm using an old piece of wood, which is a great test for this scroll saw that I bought. It's really making short work of cutting it. After cutting these 2 pieces of softwood, I've drilled holes in each end of them to allow me to screw them down to the bench. Generally speaking, from my experience, The braking system on a miniature traction engine is diabolical, and that includes the braking system on my 4.5-inch scale Burrell Showman's engine. Once I'd finished using the scroll saw, I put the guard in position. Then I screwed the 2 pieces of wood onto the bench. This one, nearest me, is near the edge of the bench, but the piece at the front is not at the edge of the bench, it's nearer to the traction engine. This is just a precaution to stop the engine from rolling off the bench. It would roll off the bench if it was in gear, it would just climb over these pieces of wood, but that is not the issue. It's just a safety precaution. Without these pieces of wood in place, the engine could easily roll off the bench. Here I've applied the brake. This makes it difficult to move the engine on the bench, so it should be okay. And to put the engine in gear, there is a locking pin that needs to be removed, so it's quite safe now. The first thing that Sean, the owner, asked me to do was to replace the blowdown valve on the boiler, and this was done by replacing the original, difficult to get to and damaged blowdown valve with a commercial steam tap. I was also told that the injector didn't work and just leaked water permanently from the tank. This injector water valve is no good at all. I can see that it's been crudely soft soldered and the shaft that goes into it is very rusty. I intend to make a new fitting to allow me to use a commercial water valve. This could prove to be a tricky job, time will tell. The list of small problems was mounting. Sean also said that the top of the water gauge dribbled. Well, I'm not too worried about that. But then he mentioned there was a bit of a dribble from underneath these 2 taps, and when I look how slack the left-hand one is, I'm not surprised. The only problem is, to remove this tap entirely, I do have to move quite a few parts of the engine. That, of course, can be a problem because it's very easy to create more problems as you start the job. Time to test the regulator, and I need some compressed air for this. With the regulator fully closed, there's a bit of a hissing noise going on, but the flywheel is not rotating. Once I open the regulator and move the flywheel, it immediately bursts into life. And it actually sounds slightly better than I was anticipating. Before running the engine for an extended period, I think it's a good idea to oil everything. And by the way, I'm using steam oil. I'm trying to do a little bit of gap filling. This should make the engine run slightly more quietly. Only the very worn or incorrectly fitted parts should make a noise. I'm sure that as this repair job progresses, I'll find other things wrong with the engine that I will put right. It's somewhat of a bonus really, because if there was nothing wrong with the engine, there wouldn't be a video. As you can hear, the steam oil is doing its stuff and there's not quite as much knocking going on. I feel that I must mention at this stage though that that is not the repair. Here I'm using a live centre from one of my lathes to apply some pressure on the end of the crankshaft to stop it from moving from side to side, but it doesn't make much difference. The valve timing is not too bad in both directions. If anything, it's just very slightly retarded, but that's quite useful for certain applications. I'll stop talking for a short while so you can hear the engine running. I think I've covered most things in this initial overview video. The first repair job will be on the end of the crankshaft and the flywheel. This is a bit of a mess. The key's not right. I don't know how you're supposed to remove this. There's a very badly damaged taper pin that's been hammered into position. This, I suppose, is okay to stop the flywheel from falling off the crankshaft, but it's not a good solution. Before I finish this job, I will refit a taper pin that isn't quite as mashed up. I will start the next episode by making a new key for the flywheel and crankshaft. Stay safe, stay healthy, thanks for watching, and I hope you found it useful. Please take the time to visit my Mainsteam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.